Math 21ers, let's take a deeper dive into this whole difference quotient idea. So we've talked about how a difference quotient, when you hear that term, difference quotient, that you're going to be subtracting something and you're going to have a fraction. Let's define it a little bit more distinctly. So a difference quotient is an expression that represents the difference between two function values divided by the difference between two inputs. So we're going to have two function values divided by the difference between two inputs. And I should say the difference between two function values and then the difference between two inputs. Now, if we refer back to the previous page, and I'll just kind of write it in here, we had said slope was a difference quotient, right? y2 minus y1 over x2 minus x1. We're going to make that look fancier in that we're going to use function notation now. So instead of the y's, you're going to see f of x's. Now I'm going to erase that for now because we don't typically, once we move into function notation, we don't tend to shy away from it. So if you have a function, right, and we're going to pretend I've got this function shown at right, and let me just pull my highlighter out. So let's pretend that curved part of the graph is my function. I'm going to put my pencil down and let's pretend, here's my function. So just so we're clear, this here, oh, and I can barely highlight that. There we go. That is f of x, okay? The function, y equals f of x. So that's the one that's shown at the right. Now, when we talk about the slope of a secant line, it's always, whenever you hear secant line, it basically means a line between 2 points on the graph. When you get to calculus, you're going to hear about slopes of tangent lines, and that's a line at 1 point versus a secant line is a slope between 2 points. All right, and sometimes that can be a little conflated with the trig functions of sine, cosine, tangent, secant, cosecant, and cotangent, but just know that those are separate. All right, so secant line, whenever you hear this, let me go ahead and write this. This is a line between 2 points. All right, and when we get to calculus, and I understand we're not there yet, we're going to talk about tangent lines, which is a line at 1 point. All right, but with our 2 points, we're going to start at f of x. So we're going to have some x value here, and then we're going to travel h units down the x-axis and arrive at x plus h. So we're going to have x and x plus h as our two input values, right? So when we talk about the difference between two inputs, we're going to talk about the distance or the difference between these two x values. So you could imagine, like, if this was 1 on the number line and this was 3, then h would be 2, right? The difference between those would be 2 units down. And the difference between x and x plus h is literally h, because we moved h units further down the x-axis. All right, so if we have our first input at x, we know its output is f of x. So there's my first ordered pair, right? And then if I have this second input of x plus h, we know its output is f of x plus h, whatever that winds up being. And so there's my second ordered pair, right? So when I say between 2 points, one of my points is x, f of x, and one of my other point is x plus h, f of x plus h. And when we're talking about the slope of a secant line, right, if I want that expression, basically what I want to do, and I'm just going to kind of color that in. That's supposed to be turquoise. I don't know how well that shows up. I want that slope. So the slope between these 2 points is going to be the change in the y's over the change in x, right? y2 minus y1 over x2 minus x1. But instead of using y2 and y1, we're going to use function notation. That's kind of how we take a step up from our slope formula that you get introduced to in your earlier math careers to this new difference quotient, which you're getting introduced to midway through your math careers. So when we talk about a difference quotient, right, if there's a function f of x, the difference quotient for that function is defined as, right, change in y over change in x, but it's f of x plus h minus f of x, right? I'm going to take the difference in the y's, f of x plus h minus f of x, right? And I'm going to do in ratio, right, as a quotient to the change in x, x plus h minus x. And that's where these are coming from. So change in y, y2 minus y1 over x2 minus x1. And the only thing here is that if we simplify this denominator a little bit, the x's cancel out and leave us with just h. So this is a real typical difference quotient. That expression, very, very common. Sometimes, as we saw in example 4, sometimes there'll be numbers here. You might see like g of 2 minus g of x over x minus 2. And that happens frequently enough, but this is also a pretty common form of a difference quotient. And ultimately, again, a difference quotient, you're going to have a quotient, so you'll have a fraction, and you're going to have a bunch of differences. So people are going to be subtracting things, right? So we subtracted some y values, right, some function values, and we subtracted some input values, some x values. All right, so let's practice this now. We're going to practice this with our function in example 5. So as I start to, let me scooch this up just so we can see it. We're going to find our first difference quotient. And I'm going to go ahead, I'm going to just kind of scooch this up as far as I can before it's out of view. So I'm going to kind of stop here-ish, just so we have a good chunk of room to write this. Now, a lot of times when I do difference quotients, it's pretty algebra heavy, and it's going to take me a minute or so just to get through this. So typically what I will do, right, here's my function. I've got this parabola, and I want to find the difference between f of x plus h and f of x, and I want to put that in ratio or in a fraction, in a quotient to h. So what I tend to do is I find this quantity separately, I find this quantity separately, and then I do the difference, okay? So you're going to see me do a little bit of side work. I'm going to do, we could almost call it my side hustle. So let's talk about f of x. We know f of x is 3x squared minus 7x plus 1. Now I also want to find f of x plus h. I always want to find both of these because that difference in my numerator is comprised of f of x plus h and f of x. So let me find both of them. All right, so let me go ahead and play this out. Now f of x plus h will be 3 times x plus h squared minus 7 times x plus h plus 1. Now I'm not going to distribute this square over this binomial. I would need to FOIL it out. So I'm going to do a bunch of algebra. So give me a moment. Let's do some algebra. This is going to be 3x plus h minus 7x minus 7h plus 1. So let's keep going. So we have 3. Okay, if I FOIL this, we're going to have x squared for first. Outer and inner are both xh, and those are going to be common, or excuse me, like terms. So I'm going to have 2xh plus h squared, all right, minus 7x minus 7h plus 1. Let me distribute this 3, so we're looking at 3x squared plus 6xh plus 3h squared. Oops, let me make that square there. Oh, that does not look good. Give me a minute. Not a minute. Give me a sec, gonna erase it. Minus 7x minus 7h plus 1. Okay. Now, when I take a look at all of this, I don't see any like terms, so I'm just going to go ahead and like pause, right? Like that is f of x plus h in all of its glory. So now let me return to this difference quotient, right? So I'm looking at f of x plus h minus f of x in ratio to h. Okay, so for substitution's sake, all right, I'm going to put this in a bracket and this in a bracket, just so you can see me work this, especially the first time out as we're going through this together, right? So f of x plus h is this thing, but I'm gonna write this as, this would have been 3 times x plus h squared minus 7 times x plus h plus 1, right? I'm gonna subtract out my original function, which was 3x squared minus 7x plus 1. And I'm going to put that all in ratio to h. So let me try and clean this up, or kind of clear this up, right? For this particular problem, right, f of x plus h was this whole string of things, right? I basically substituted this line here. All right, so this first line, I'm not sure if you can see, let me scooch this just a little bit to my left so you can kind of see the end of this paper here. All right, so I substituted this line, right? And then for f of x, I'm going to substitute this line. So this is the first pass. Me literally subbing in what is my particular function evaluated at x plus h? What is my particular function for this problem evaluated at x? So it's this quantity minus this quantity over h. Once I'm through here, all of the algebra is going to play out. Now, I already did all of this algebra, right? That's what all of this is. So I'm going to take this thing, all right, and I'm going to put it in here because I've already done all of that algebra. So let's try this. I'm going to give myself a lot of room because these are very algebra heavy once we get going on this. So this is going to be what, 3x squared plus 6xh plus 3h squared minus 7x minus 7h plus 1, minus 3x squared minus 7x plus 1 all over h. Okay, so in a moment, what I'm going to do, I'm going to drop the brackets. I'm going to distribute this negative. So ultimately on this back end here, I'm going to have minus 3x squared plus 7x minus 1. Okay, and I'll write that all out in just a bit, but I also want you to hear, once you start doing these enough, you're going to see a slight little pattern play out. And I'm going to mention it now, and then I'm going to double back to it as needed. When you have these polynomials, right, just a basic, polynomial here, it's a quadratic, cubic, whatever. Oh, wait, let me back up. We definitely have a quadratic. I meant to say, like, if you have a cubic or a quartic or any kind of polynomial, and you're working through the difference quotient, once we simplify a little bit and start canceling things, a little kind of flag, like a green flag, actually, that you've done things correctly, is that all of the terms from f of x should cancel out. So when I start to simplify this, if I've done this right, a little green flag for me is to see, did something cancel with 3x squared, 7x, and 1? And if they did, it's a little bit of a green flag that I'm doing this correctly, right? And if it didn't, it's a little bit of a yellow flag saying like, hey, go check your algebra for a minute. All right, so let me go ahead. I'm going to put the equal sign over here just because there usually is so much algebra. So I'm going to drop the brackets and distribute that negative sign. So we've got 3x squared plus 6xh plus 3h squared minus 7x minus 7h plus 1 minus 3x squared plus 7x minus 1 all over h. Okay, so I dropped the brackets and I distributed that negative. And now let's see if these three terms, the 3x squared, the 7x, and the 1, get canceled anywhere. And if I start to look at this negative 3x squared here has a counterpart of positive 3x squared here, and they do cancel. That is a good sign, okay? So we've got a little bit of a green flag here. All right, the next thing I want to see, does 7x cancel with anything? And if I go through this, I can see there's a negative 7x here. So yes, those are going to cancel as well. Great. Another green flag. And then I see this minus 1 here, and I do have a plus 1 as well. Those are going to cancel. Those are all green flags. So whenever I start to go through difference quotients, I just check, did my original function cancel out? If it did, great, green flag, time to move on. If it didn't, yellow flag, go check your algebra. Because there's so much algebra happening in these problems that it's not unheard of for there to be some kind of little typo that we have to fix. So let me just see what's left at this point. What do we have? It looks like we have 6xh plus 3h squared and a minus 7h all over h. All right, and what typically happens, this next thing is pretty common also, is a lot of times there's an h common to the terms in the numerator, and we can factor that h out, and then we can cancel it with the h in the denominator. So what I mean by that, I'm going to put my equal sign, I'm going to factor out an h, I'm going to have 6x here, minus 3h, minus 7, and I'm going to have that in ratio or in fraction to h, in quotient to h, that's going to cancel. And ultimately, that's going to leave me with 6x minus 3h minus 7, and that is my difference quotient. Oh, and gosh, maybe you're spotting my typo, maybe you're not. I actually see my own little typo. So I noticed that this was a plus here, so I better put that as a plus, and that would change my endgame answer to a plus here. So if you saw that while I was going through it, awesome. And if not, welcome to the world of making typos all the time. All right, so all of that algebra, right? That difference quotient is ultimately 6x plus 3h minus 7. And just kind of looking forward, once you get into calculus, you'll add an extra algebraic step here with something called a limit. We're not going to do that, obviously, because we're not in calculus yet, but this is like most of the problem you'll have to do in calculus, and then you'll add one more step to it. All right, thanks so much. Bye.